Please go through the question, pause the video, and try to solve it yourself first. The question says a wide cylindrical vessel of 50 centimeter height is filled with water and rests on a table. So this is the vessel, right? Assuming the viscosity is negligible, find at what height from the bottom of the vessel a small hole should be perforated for the water jet coming out of it to hit the surface of the table at the maximum distance L max from the vessel. So let's say here is the hole and the stream of water comes out and travels a distance of L. This is the height of the vessel H, and this is the height from the bottom of the vessel at which the hole is perforated. So we have to find out at which small h L is L max, right? So to find out velocity at this point, you have to find out the pressure at this point. So pressure at this point will be because of the water column above this point. So to find out the velocity, we have to use Bernoulli's principle. The pressure at this point is rho gh, rho into g into h. Now this h is capital H minus small h. This will be equals to the velocity half into rho into v square. This is the head because of pressure, and this is the kinematic head, right? So this is the first equation. From this velocity we can find out this length. So length is equals to velocity into time. Now we have to find out time, what time it takes for a water droplet living at this point to reach the bottom, right? So the vertical velocity is 0, 0 is equals to, this is the vertical velocity, right? We have to write a equation S equals to ut plus half gt square. This is the equation that we will be using, right? Now u we know is 0. This S is equals to h, right? Half into 10, g is 10. We are assuming g as 10. Now this is t square. H by 5 root over, right? This is the value of t. Now this L is equals to v into root over of h by 5 if we substitute the value of t here, right? Now from this equation we will substitute the value of v, right? Now L is equals to, the value of v is, these two will cancel out, 2g h minus h root over into root over of h by 5, right? Now we have to make this maximum. So we have to differentiate this equation, right, with respect to h and make it 0, and then we have to find out the value of h, right. So this is 10, so 225 h minus h into h root over, this will be 4, right. So this will be 2 into capital H into h minus h square d of dh is equals to 0. Now this inside the square root thing has to be, you know, maximum. So after differentiating we can get h minus 2h equals to 0 and h is equals to h by 2. So at h equals to h by 2, this L will be maximum. The answer over here is 25 centimeters because h is 50. This one.